Hi math lovers, welcome to notes number 51, lesson 2.7 on inverse functions. We're going to talk today about how to come up with the inverse. So we talked the other day about inverse functions, and the shorthand notation is this little -1 up at the top. It doesn't mean reciprocal, it means it's the inverse. So if you think about your reciprocal is the multiplicative inverse, because one is going to undo the other. So if I'm multiplying by something, I'm going to get a number. To undo that multiplication, I would divide by something. So I'm really multiplying by the reciprocal. So a couple things. First of all, if a function passes the horizontal line test, remember we did the vertical line test to find out if something was indeed a function. But now we're going to do the horizontal line test. And that's going to determine if it's one-to-one. We're going to determine if it actually has an inverse. All right, so keep that in mind. First thing you're going to do is look at a graph, check its vertical line test. Yes, it's a function if it passes. Then check the horizontal line test, and that'll tell me if it has an inverse or not. To find the inverse algebraically, what we're going to do is first make sure that it's a function. And then I'm going to take the f of x notation and change it to y equals form. I'm going to switch my x and y's and then solve for y and then put it in that fancy form. I know what you're thinking, Glennon, let's do an example, right? So 75, from your textbook, it's written as f of x is equal to the square root of 2x plus 3. All right, so your first step is to make sure it's actually function. So what you are going to do is you're going to go ahead and make that graph. It looks something like this. You pop it in your Desmos or pop it into your graphing calculator, and you can make sure, yeah, it's going to pass the vertical line test. I'm also going to, while I'm at it, check its horizontal line test to make sure it has a function. It has one-to-one, so that passes it too. Now I'm going to switch f of x into y equals form. Y equals the square root of 2x plus 3. Now I'm going to switch all the x's and y's. I know it seems crazy, but that's exactly what you're going to do. Every x becomes a y and every y becomes an x. Now I'm going to solve for y. In order for me to get rid of that square root sign, I'm going to square both sides. So 2y plus 3. Let's solve for y. Let's move that 3 over. So x squared minus 3 equals 2y. Divide everything through by 2. X squared over 2 minus 3 over 2 is equal to y. My last step is to write it in that fancy form. F inverse of x is equal to x squared over 2 minus 3 halves. All right? Now what I'd like you to do is to pull out your TI-84, all right? Your TI-84, and you're going, oops, I got a graph already on there. Let me clear it. All right, so what we're going to do is we're going to put in the square root of 2x plus 3, okay? And I can go ahead and graph that. Take a look at the graph. All right, so here's the graph of it. Now what I want to do is I want to go back to my y equals, and let's put in this new graph that I came up with. That would be x squared, oops, oh, clear. I messed it up. Hold on a second. Technical difficulties. I didn't hit that enter button. X to the second power. There we go. It's taking me just a second, everybody, to type it on in. Divided by, I'm still here. Okay, so I've typed it into my calculator, and I'm going to go ahead and I'm going to graph both of those functions. Okay, so there it is. There is my function. Notice that this is a parabola. All right, and this is what I'm trying to get for you to see. My inverse is not going to be a parabola. My inverse is actually only going to be the reflection over the identity line. So my inverse is going to look like this. So this is f inverse of x here in the pencil, and in pen would be my f of x. Okay, so I have to tell my reader, hey reader, don't use that other part of the graph. All right, so we're going to restrict our domain. We're going to say, hey, my domain is only to use the positive values of x. So x has got to be greater than or equal to 0. So kids, what you're going to have to do is, I should probably add step 6 here, right? Check your domain. That's a good addition. That's a new addition. New addition for 2020. Make sure you check your domain there, okay? So I already spoiled my next part. It's really the reflection over the y equals x line, which is the identity. So it's a really small graph I made here. You can see that this is going to be the reflection over the identity. So there are two ways you could go. You could do it algebraically, like we did here, following all the steps. Or you could, if you're just given a graph and somebody says, hey, find the inverse, you can go ahead and you can graph it, okay? Ready to try another one? All right, go to the second page over here. I'm going to give you a problem. It's number 27 from your book. They're going to say f of x is the function x cubed over 8. And they're going to give you the function g of x is equal to the cube root of 8x. All right. Now you want to prove, oh, you love those proofs, prove that f of x and g of x are inverses. Okay, so those are your directions. Prove that they're inverses. So over here, I have the rule. To prove that functions are inverses, you're going to prove that f of g of x is equal to g of f of x. All right, so we're going to use that. So in order to, I'll say f of g of x is equal to g of f of x. All right. So I'm going to start with one side of this equation and I'll substitute it. I really don't know if they're equal. Do I? I mean, are they equal? I should put a question mark because I'm going to figure it out. Let's start with the f function, and inside the f function I'm going to put the g function, which is the cube root of 8x. Okay, and then I'm going to take the cube root of 8x and I'm going to put it into the f function. So everywhere I have an x, I'm going to put the cube root of 8x over 8. Okay, makes sense so far? Oh, wait, I forgot to cube it, right? Oh, that would be silly of me. So if I cube the cube root, that's just going to be 8x over 8, which is x. All right, now let's work with this other side. G of f of x. So I have g of f of x. In the f of x is x to the third over 8. Now I'm going to take that x to the third over 8 and put it into the g function. So that would be the cube root of 8 times x to the third over 8. Oh, look at, well, I should make it be longer. Look at how nice it is. These are going to fall right out, aren't they? Beautiful. So I have the cube root of x to the third, which, my friends, is x, and x is equal to x. Woohoo! So I have just proven that these are inverses. Okay? Now, how about the graphs? So because I don't want to make this video so long, I would like you to take these two graphs, pop them in your calculator. I will, but if you want to stop here and try it on your own, that's okay too. All right, give me a second. I'm a little slow with typing these into my calculator. You're probably going to beat me. I need that cube root sign. Where's that cube root sign? It's in the math menu. Cube root of 8x. Okay, so now I've typed them in. Moment of truth. Oh, look at it. Oh, look at it. Can you see it? Okay, I'll get a little closer here. Okay, can you see it? Now what will really, let me kick it up a notch and let me add a line in here, the identity line, so you can see that I really do have indeed the reflection over the identity line. Look at that. Isn't that beautiful? Ooh. Now, if someone asked you to prove it, I would not necessarily use the graph to prove it. I would probably use the old-fashioned algebraic proof to make sure that that's true. Okay, so again, your steps to finding the inverse: make sure it's a function, change it to y equals form, switch the x and y's, solve for y, write it in pretty form, and make sure you check the domain. The second big thing we learned today is to prove functions are inverses. Make sure that f of g of x is equal to g of f of x, and then you've proven it. All right? Have fun with your problem set.